Hello and welcome to day 7 of our Building a Campus Network. And in today's network, we are going to optimize spanning tree. At the moment, we have 3 networks running within our campus network. We have VLAN 1, VLAN 10, and then VLAN 20, as we can see over here, respectively. So back on call switch 1, if I type show spanning tree VLAN 1, it shows me that this call switch 1 over here happens to be the route for VLAN 1. So with that, traffic from VLAN 20 traveling to VLAN 10 would first have to travel to all the way up to call switch 2, where we'll be configuring as the default gateway for VLAN 20 before traveling to VLAN 1 on call switch 1, which happens to be the route for VLAN 1, as we can see over here. So what happens if this link goes down? Can we be able to ping VLAN 1 from VLAN 20, although we have redundant links over here? Okay, so back again, we can type show spanning tree VLAN 10. Show says that this same bridge happens to be the route for VLAN 10, and that's quite acceptable because traffic traveling from VLAN 10 will go all the way up to call switch 1 over here. So what about VLAN 20? So show spanning tree VLAN 20 shows me that call switch 1 happens to be the route for VLAN 20, which implies that traffic sent from VLAN 20 on PC2 would have to travel all the way up to call switch 1. Nevertheless, VLAN 10 over here travels all the way up to call switch 1. So why wouldn't VLAN 20 with PC2 on that network wouldn't have its network traffic going all the way up to call switch 2 before it can be transversed into the network and to other workstations? So that's what I'm going to do, and it's called optimizing spanning tree. So basically what we are going to do is we're going to make VLAN 1 and then VLAN 10 to be on route 1, which will be acting as the route for VLAN 1 and VLAN 10, and then VLAN 20 will be on call switch 2, which will be the route for VLAN 20, and then we will configure a VLAN 20 on call switch 1, but in this time it's going to be a backup. So should in case call switch 2 is down, the link will go all the way up to switch 4 and then through the redundant link to call switch 1. So with that, assuming this interface goes down, or this interface goes down, or this link is off, the call switch 1 over here will be acting as the backup route for VLAN 20. So without wasting much time, let's go ahead and make switch 1 the core the route for VLAN 20. So config t, so spanning tree VLAN 10 priority, and as you can see, the lower the priority, the more is accepted as the route. So as you can see, the interval goes from 0 and then all the way up to 61,444. So, and it goes in the increment of 4,096. So as we want VLAN 10 to be the route on call switch 1, we are going to use a priority of 0. Same applies to VLAN 1. So show spanning tree VLAN 1 priority 0, and I said that we are going to configure call switch 1 as the backup route for VLAN 20 on call switch 1. So spanning tree VLAN 20 priority will be so the next increment will be 4096. Okay, and we are good to go. So back on call switch 2, we are going to make call switch 2 the root for VLAN 20 and the backup root for VLAN 10, so that should in case this link the link on switch 3 goes down, traffic to VLAN 10 will use the redundant link on core switch 3 to all the way up to core switch 2, sorry, access switch 3 all the way up to core switch 2 over here. Okay, so en config t, so spanning tree VLAN 20 priority 0, making it the root for VLAN 20 on core switch 2, and the backup root for VLAN 10 and VLAN 1 on core switch 2. So 4906.4096. So spanning tree VLAN 1 priority 4906 exit. So now let's check our spanning tree. Show spanning tree VLAN 1. Show says that this bridge happens to be the root for VLAN 1, so therefore all traffic to VLAN 1 will be directed towards core switch 1. Show spanning tree VLAN 10 shows us that VLAN 10 is configured to be on core switch 1 as its root, so therefore all traffic configured directed to VLAN 10 will go to core switch 1, and it will only go to core switch 2. That's when the link to the core switch 1 from this access switch is down. Okay, so back on switch 1, let's check on show spanning tree VLAN 20. Shows me that there's a cost of 3 to travel to the root bridge, and the root has a MAC address of this, and it has a priority of this, and that's the bridge ID for this particular switch. So this shows me that VLAN 20 has been configured as root on core switch 2, and therefore as you can see the MAC address happening to be that one from core switch 2. So let's verify from here. So back on core switch 2, show spanning tree VLAN 1. Okay, so spanning tree VLAN 1 shows me that it has a cost of 1 to travel to the root bridge, and as I said, this is the MAC address. Let me do it this way. This is the MAC address of core switch 1, and as you can see, that's the root ID on core switch 2 over here, and it has a cost of 3 traveling to the root bridge, and the root bridge happens to be core switch 1. So core switch 1 is the root for VLAN 1. So what about VLAN 10? VLAN 10, same applies to VLAN 10. VLAN 10 has been configured as root, and traffic to VLAN 10 will be directed towards core switch 1, and as you can see, it has MAC address of core switch 1 as its root ID, and the port connecting to core switch 1 is 65, which is port channel 1, and as you can see, this is the bridge ID. So let's check for VLAN 20 over here, and as you can see, this bridge is the root for VLAN 20. So if you configure VLAN 20 on core switch 2 as its root, and therefore traffic to VLAN 20 will be channeled to core switch 2, and it will only be channeled to core switch 1 only when the uplink to core switch 2 from VLAN 20 is down. And as you can see, if you compare the configurations, this is core switch 1. You see it has a priority of 20, same applies here, and the address of the root ID is that of core switch 2. It has a cost of 3. VLAN 20 on core switch 2 has no cost, and therefore it happens to be the root for VLAN 20. So that's how to optimize spanning tree, and we can also check from core switch 3 over here. So en show spanning tree, show spanning tree. So as you can see, spanning tree VLAN 1 has a cost of 100 and it is on interface 00. That's connecting to core switch 1, which happens to be the root for VLAN 1. So what do we have again? VLAN 10 has the cost of 100, sorry, on port 00. So VLAN 10 has been configured as root on this interface. And what do we have again? VLAN 20, it has a cost of 100 through port E01, which means core switch 2 has the root by VLAN 20, and therefore traffic from PC1 all the way up to VLAN 20 will traverse through interface 01 to VLAN 20 on core switch 2. So that's how to optimize spanning tree, and in my next video we are going to see how to test spanning tree. Thanks for watching this video and see you in my next video.